Greetings, everyone. Today we're going to explore systems of linear inequalities. There is a sheet for guided notes to put in your notebook to make it easier, and also some colors would be very helpful to differentiate some of the ideas as far as linear inequalities. In your notes foldable, let's go through some basic steps of graphing linear inequalities. First step, super easy, right? We've got to graph the line. That's something we're not going to review in class. I'm going to make the assumption that you know, and I've seen some of you take care of that in class already. Next, we need to decide if it's a solid or a dashed line. Remembering those rules, what makes it a solid line? What makes it a dashed line? We then need to shade according to the inequality. Remember, so it's step 4, it's not really a step, it's more of a remember. Remember to flip the inequality sign if dividing or multiplying by a negative, because that will change the direction of your line. And just a side note here, don't forget about horizontal and vertical lines. So horizontal lines are always going to be y equals a numerical value, and vertical lines are always x equal to to a numerical value. So let's take a look at this first example. To start off, let's decide if it's a solid or a dashed line. So in this case, it's going to be a dashed line because it is less than, right? Solid lines are always or equals to, and since we don't have that, it's going to be dashed. Next, we need to graph our line. So as I take a look, I need to decide if I want to do a table of values, if I want to put it into slope-intercept form, if I want to put it into point-slope form or translative form. You have to decide. So I'm going to put this in a slope-intercept form. It just seems like the easiest option for me. But if you choose something else, please write it down that way. I'm going to rearrange those right away. Divide everything by a -3. So because I divided by a -3, I have to flip that sign. So don't forget that. Now I can graph my line much easier. So I'm going to start at a y-intercept of -4 up to over 3. Continue those dots. You'll notice that when I graph, I usually include a lot of dots because typically I don't have a straight edge to use, especially on a tablet like this. So for me, I'm a little more accurate if I got the dots. So now I need to decide what side I'm going to shade on. Ooh, but does anyone notice a mistake? I need to make this a dashed line. So I'm just going to take my white pen here because I don't have an eraser option, and I'm going to erase part of my lines to make it dashed. When you're going through this process, a straight edge might make it a little bit easier to do a dashed line because then you can just go along the straight edge or ruler. It could be the edge of your book, notebook, binder, whatever you need to make that dashed. Now for shading. For shading, there are different ways to go about the shading. I choose to use a test point. Okay, so for a test point, I typically, if I can, use the origin of 0, 0. Meaning I need to pick a point on one or the other side of the line. If 0, 0 is on the line, I can't use it. So in that rare occasion, where my line goes through the origin, I need to pick a different test point. So now for that test point, I'm going to take my original inequality and I'm going to plug in 0 for my x and for my y. When I solve, I end up with 0 minus 0, which is 0 less than 12. So I now need to decide, is that a true statement? Is 0 less than 12? And it is. So because this is true, this test point is true and needs to be shaded. So in that case, I'm going to shade on the side of the 0, 0. Okay? So I could use any test point. I could have used 0, 10, and it would have worked. I could have used negative 10, 0, and that would work as well. You can pick any point. You have infinite amount of points to choose from to plug in and see if they work. So now let's check our answer. To check our answer, let's pick a point on which we have shaded. Now you might do your test point work in that checkbox. That's up to you if you want to prove it that way. I like to do another check and just double check. So I'm going to pick that point 0, 10, and I'm going to see how that works out. It should be true. So I'm going to use 0, 10, plug in 0 for my x, 10 for my y. I end up with 0 minus 30, which is negative 30 less than 12. That's a true statement. So yes, I know that this point is shaded correctly. So far, this should be a little bit of a review. You get into this in Algebra 1, you take care of shading, but now we're going to take it up a notch. Let's do one more review here. Let's take a look at graphing these two linear equations. So the first thing you might do is transform them into something that's easier for you to graph. I'm going to transform this one into y equals negative x plus 10. It's just easier for me to see. And if I do a little bit of work here, I'd have a negative 3y, a negative 2x, positive 12, which will get me to a 2/3 x minus 4. So if I graph those two lines, I'm going to start by graphing this first line in blue. Just have 10, slope of negative 1. I'm going to do more dots just to try and be a little more accurate. Okay, connect those dots. This is an equal sign, so I'm just reviewing what that looks like. And then the second equation, I'm going to graph that, negative 4, rise 2, run 3, rise 2, run 3, rise 2, run 3. Oops, did I make a mistake here? Let's try this out. Okay, I'm going to go the other direction as well. Down to left 3, down to left 3. I'm just going to try to make as accurate of a graph as I can. Now if I connect those dots, right, you'll notice that these two lines intersect. And we've talked about this a little bit in class. And that point of intersection, we call that the solution. Okay, so that solution is going to be a point where the lines intersect. So in this case, we called this, the formal description is a system of equations. We're solving it graphically. And the solution is a point where the lines would intersect. One point xy that works in both equations. So this isn't anything new again. But what we're going to do is we're going to combine that idea of linear inequalities and systems of equations. Meaning we're going to have two lines, but now they're going to be inequalities, which means now we're not going to have just a single point solution. We're going to have infinite point solutions. So let's meld those two ideas together. This one, you definitely want to get this down in your notes. So this is what's going to be newer. So I'm going to start off with these two inequalities that I need to graph. So to start graphing these, I'm going to put them in a form that's easier for me to graph. You decide what that form is for you, whether it be a table of values, point slope, slope intercept, you decide. So I'm going to first start by kicking that x over to the right side of my inequality. And on this one, I'm going to start by subtracting x to the other side. And then I'm going to divide by negative 3. Now when I divide by negative 3, it's a negative. So I have to remember to flip my sign. Negative 1 divided by negative 3, positive 1/3. 8 divided by negative 3 would get me to negative 8/3. All right, seems a little bit messy, so some of you might think maybe point slope form is easier, but let's go with it. We can take care of this on our graph, no problem. So I'm going to start off. You'll notice I have different colors here. Here's where you might want to start using those colors that I recommended at the beginning of this video. So to start off, I'm going to start 4. I have a slope of -1. And here's where the colors are really going to make a difference is when we shade. We want to see where our colors overlap in shading. Solid or dotted line, make sure you remember that. This is less than or equal to, so this line's going to be solid. Okay, now I need to decide which side to shade. So in this case, I'm going to use the test point 0, 0 because it's sort of below the line. So if I do that quick check, 0 less than or equal to -0 plus 4, which would be 4 is greater than or equal to 0, that's a true statement, okay? So that means that I would lightly shade on this side of my line. Now, by lightly, be very careful, be confident in your answer, because if you shade using colors and you're incorrect, you might have a little bit of a problem there. All right, let's take a look at our blue line. So our blue line, I'm going to graph that. Now, -8/3 is a little bit less than 3, okay? Or excuse me, a little bit less than -3. So it's about -2 2/3. So make that estimation on your graph. From there, we're going to rise 1, run 3. It's going to be a little bit above the line there. That's okay. Keep going with it. Rise 1, run 3. And remember, this is okay because I am not looking for an exact point with systems of linear inequalities. I'm looking for a range of values. Okay. To graph this is less than, so it will be a dashed or dotted line. All right, now we need to take care of the shading, which means I'm going to use that 0, 0 test point again. So when I plug 0 into my original or new inequality, you can decide. I think actually the original might be easier. So I'm going to do 0 minus 3 times 0 greater than 8, which will give me 0 minus 0 is 0. Is 0 greater than 8? That is not true. Put a slash through that. You're telling me I understand that that is not a true statement, which means 0, 0 should not be shaded. So with my other color, I'm going to lightly shade on the opposite side of 0, 0. All right, so don't shade 0, 0 because it was not true. So now the goal here is taking a look at where my two colors overlap. That's my region of values that would be true for these inequalities. So I'm just going to amplify that region. So we'll go along this line and out, along this line and out, and then everything shaded from there out. Okay, so I'm just using another color to emphasize where that overlap is. Since you're doing this on paper, I'm sure it'll be a little bit clearer. You wouldn't have to color even more. Now, if I wanted to check my solution and make sure that I'm right, I could pick a point within that double shaded region, and it should be true for both inequalities. So I'm just going to do a quick check here. This point would be 4, -4. So if I plug that in, it should be true in both inequalities. So that would mean a -4 plus, excuse me, a +4 plus a -4 less than or equal to 4, which would be 0 is less than or equal to 4. True, that's good. Then I'd have 4 minus 3 times -4 greater than 8, which would be 4 plus 12 greater than 8. Is 16 greater than 8? Yes. So I'm confident that that point is a true solution for both of my inequalities. Some students ask, can I just pick a test point and see where the double shade is right away? Now, I prefer that you take care of each individual linear inequality first. I want to make sure that you understand that more simple concept before jumping into the more complex. So, a couple of notes. A solution to a system of linear inequalities is a region of points where the shading intersects, which to generalize means that all the points work in both inequalities. If you need to pause or rewind to take care of any of the notes on this slide, please do so. All right, let's take a look at one more example. No notes, just an example to work our way through. First, we need to take care of graphing. Again, determine if you would do point slope, if you would do a table of values, do what you need to do first, okay? I connect with slope intercept, so that's why I'm going to subtract that x over, which gives me my first linear inequality. And I'm going to also, on this one, it's a quick move, I'm going to add 6x over so that I have my second linear inequality. Oops, and I'm actually going to fix that up because I wanted to use different colors. So let me redo that really quick and fix my handwriting. So I have a positive 6x plus a 1. So purple line, draw your points, your linear, decide if it's solid or if it's dashed. In this case, they both are not or equals to, so they're both going to be dashed over dotted lines. You decide. Just have something to connect. Even if your graph's small, don't just leave dots. We need something more than dots. Also, I'm going to stress, we need arrows on the ends. These are lines. They go on forever, so we need to show that on our graph. I'm going to start at 1. I'm going to go up 6 over 1. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I can really only do 3 dots to make this one work, so I definitely need to fill in with dashed lines. Here's where a straight edge or the edge of your binder would be your friend, because as you can see, mine's kind of sloppy. So let's start off with determining our shading. So first of all, our purple line, 0, 0 would make a good test point there. If I plug it into the original, 0 plus 0 is greater than -3, 0 is greater than -3, true statement. So I'm going to lightly shade on the 0, 0 side of my purple line. Take a look at our blue line. Oh man, if I look at our blue line, 0, 0, depending on how sloppy your graph is, like mine, I don't know exactly what side that should be on. It's not a clear point. So I want to pick a different point, okay? So I'm actually going to pick, I'm going to use 10, 0. I feel like that's clearly on the right side of my graph. Could you use any other point? Of course. I like to stick to 0s and 10s if I can. That's just a preference. So if I plug that back to the original equation, -6 times 10 plus 0 less than 1, -60 plus 0 less than 1. Is -60 less than 1? Yes, it is. So I want to shade on the 10, 0 side of my graph. And by doing that, I've now created that region of values. So I'm going to just emphasize that using a third color to show that that is my region of values. If I wanted to just take it that next step to make sure, that means that that value of 10, 0 should work for both. Well, I already proved it worked in the blue. Let me just one more quick check on the first one. So if I used 10, 0 on the first inequality, that would be 10 plus 0 is greater than -3. 10 is greater than negative. That's a true statement. So I'm even more confident that my shading is correct. So just a quick refresher of what we've done here. So we have to first graph our line. We need to decide if it's dashed or if it's solid. We then need to shade I choose to do it using a test point. If that doesn't connect with you and you need to discuss another way to prove, please let me know. Then we want to, I'm going to just sort of say double shade, right? That's what we're looking for, is the double shade or the region of points. That's our solution in the end, is that region of points. Okay. All right, so if you have any further questions, let me know. Feel free to seek out other videos to assist you in this understanding. Take a look at Google Classroom to see what our next task is, and I'll see you next time.